Welcome to section 11.3. In this section, we're going to solve equations that are not necessarily quadratic, but that need quadratic techniques in order to be solved. So we're going to start by doing this example right here, which is actually a radical equation. We solved problems like this in the previous chapter. Now I'm actually going to come back up to these steps here in just a minute. We don't really need them yet, but we'll come back to those. So let's start here. If you have a radical equation, remember the first step is to isolate the radical and get it all by itself. So I'm going to do that by adding radical x minus 1 to both sides to give us x minus 3 equals the positive of radical x minus 1. Now remember, when you have a radical by itself, you either square or cube or whatever to both sides to eliminate that radical. Because this is a square root, I'm going to square both sides. And then on the left we have x minus 3 all squared equals, on the right the square root and the square cancel and we get just x minus 1. Now this we need to figure out what kind of equation is this and how do we solve it from here. Okay, so at this step you have to re-ask yourself, what do we do? And if you look at this, you'll notice that the left side, if you expanded it and FOILed this out, would be a quadratic, and the right side is linear, which means if you combine all the like terms after expanding everything, you're going to have a quadratic equation. So this actually is a quadratic equation. So it happens, just so happens, that when you start to solve this radical equation, it turns into a quadratic. So when this happens, first you can choose your technique, first of all, for solving. You can, at this point, choose to expand everything, get everything on one side, try to factor. If it doesn't factor, use the quadratic formula. Or if you go in this order of these steps, it'll just make it a little bit easier on itself. Now these steps are not set in stone. You don't have to do them this way. This is just to make it easier on you. So first, if the equation is in this form, something all squared equals a number, you can use the square root property to solve. And that's actually what we have here. Well, no, it's not exactly, because if we did take the square root of both sides, look at what would happen. On the left side, the square root and the square would cancel, but on the right side, they wouldn't. We'd still have a radical x minus 1. In fact, that's what we started with. That's what we had up here. So that doesn't help us at all. Although it almost looks like it's of this form, it's because the right side is not just simply a number. If it was, that would be great. So we're going to have to go to step 2 and write the equation in standard form. Ax squared plus bx plus c equals 0. So let's expand this thing out here. If we FOIL this, we'll have x squared minus 3x will give us a minus 6x when you FOIL, plus 9 equals x minus 1. And so from here we can see, oh, it's a quadratic. Get everything on one side. So let's subtract x and add 1 to both sides. Negative 6x minus x is negative 7x, and 9 plus 1 is positive 10. And that's equal to 0. And now from here, factoring is usually easiest if it factors. So step 3 says, try to solve the equation by factoring. If not possible, then go to step 4 and use the quadratic formula. So let's give it a little try here and see if this maybe does factor. If it does factor, it's going to factor into x and x. The middle terms add to a negative, so these will both have to be negative, but they have to multiply to a positive. We want them to multiply to 10 and add to 7, so let's try 5 and 2. And if we FOILed this, our outside term would be negative 2x and our inside term would be negative 5x. Those add to negative 7x, so it looks like we are good to go. So from here we can just set each factor equal to 0 and solve. Now remember, one of the things about radical equations was if you ever square both sides of an equation or multiply both sides of an equation by a variable, you run the risk of introducing extraneous solutions. So we do have to check both answers here. So let's start by plugging in x equals 5 Now I've plugged in 5 for x here and here, and I'm hoping that I get 0. So let's see. We get 5 minus the square root of, that's 4, minus 3. Square root of 4 is 2, and yes, 5 minus 2 minus 3 does equal 0. So that one works. So now let's test the other answer, x equals 2. Plugging that in, we get 2 minus radical 2 minus 1 minus 3 equals 0. That's 2 minus the square root of 1 minus 3 equals 0. 2 minus the square root of 1. Square root of 1 is 1. So that's 2 minus 1, which is 1, minus 3. 1 minus 3 does not equal 0. So that one does turn out to be an extraneous solution. So we'll cross that off. It turns out x equals 5 is the only true solution to this equation. So this section, as you can see, is really a bit of review. We're going back to a couple previous things we did and just adding in a little bit more to those other things that we have done. Okay, so next we actually have a rational equation, remember, because it has fractions. So to solve a rational equation, the first step is to multiply both sides of the equation by the lowest common denominator in order to eliminate all the fractions. Well, this denominator is x minus 1, this one is x, and this one is x times x minus 1. So the lowest common multiple of all those, or lowest common denominator, is x times x minus 1. So that's what I'm going to multiply both whole sides by. So here and here is where I've multiplied both sides by x times x minus 1. So now we do have to distribute that out over that minus there. On the right side we can go ahead and cancel because everything is factored. So coming back to the left, when we multiply it out times this first term, we'll have x times x minus 1 times 2x all over x minus 1. And distributing it over the second term, we have x times x minus 1 times x plus 2 over x equals 5. Then we can cancel common factors. And so we are left with x times 2x minus x minus 1 times x plus 2 all equals 5. Now at this point you should probably stop and ask, what kind of equation is it? And maybe you can tell or maybe you can't tell at this point. So let's keep going a little further before we figure out what kind of equation it is. 2x times x simplifies to 2x squared. This, to simplify, I'm going to have to FOIL that out to get x squared plus 2x minus x is plus 1x minus 2 equals 5. And at least now it should be obvious that yes, it is a quadratic equation here. So let's keep going and simplifying and get it equal to 0 on one side. Let's distribute out that negative right there to give us minus x squared minus x plus 2. And then we can combine like terms. 2x squared minus 1x squared is 1x squared minus x. Then if we subtract 5 from both sides, we'll have 2 minus 5. So minus 3 equals 0. This is great. It's in standard form. It's equal to 0. And now we can try and see if this thing factors. Maybe it does, maybe it doesn't. We'll see. If it does, it'll be x and x. The last two terms have to multiply to 3, so the only way to do that is to have a 3 and a 1. Let's see, one of them will have to be positive and one has to be negative, but they have to add to a negative. So the negative would have to go with the bigger number, in which case the outside term would be negative 3x, and the inside term would be positive 1x, which adds to negative 2x, not negative x. So this thing is not going to factor. So it looks like we're going to have to use the quadratic formula here. So let's write it out. Negative b plus or minus the square root of b squared minus 4ac. Just write it out until you have it memorized. Okay, so let's see. We have negative b. B is the coefficient of x, which is negative 1. So negative 1 plus or minus the square root of b squared is negative 1 squared. Remember those parentheses around that negative 1 before you square it. minus 4 times a is 1 times c is negative 3 all over 2a, so 2 times 1. So we have, under the radical, we have 1. This is going to become plus 12 all over 2. So we have negative 1 plus or minus the square root of 13 all over 2. Now remember, this is a rational equation. Because we multiplied both sides by a variable, we do have to check both answers because we might have introduced extraneous answers along the way. So let's see. Let's plug in the one with the plus first. So first I'm going to plug in and check x equals negative 1 plus radical 13 over 2. Plugging that in gives us 2 times x, negative 1 plus radical 13 over 2. That's this 2x over x minus 1. So over x minus 1 minus x plus 2, which would be negative 1 plus radical 13 all over 2 plus 2 over x. As you can see, this is going to be really complicated to simplify. But we aren't going to have to simplify it, which is the great thing, because the only way this is not going to work is either, well, one of two ways, either if we made a mistake, or if one of these gives us a 0 in the denominator. And you can clearly see let's just look at denominators. Let's assume we didn't make any mistakes. This denominator is not 0, not 0, not 0, not 0. None of these denominators are 0. So this should work, and as well, so should the other one. Because the only two values of x that will give you a 0 in the denominator are 0 and 1. Right? Those are the only two values of x that x cannot equal. So all other values of x should work. Okay, so those are our two solutions for this rational equation. All right, next let's solve one like this. Now this is not a quadratic equation. This is a quadratic-like equation. It has three terms, so it can be written as a quadratic if we think of this x to the fourth as being x squared all squared minus 5 times x squared minus 36. So all I'm doing here is I'm rewriting this x to the fourth as x squared all squared, because you would multiply those two 2's to simplify this. Why would I do that? Well, it's because now I can think of it as a quadratic. I have something squared minus 5 times that same something minus a 36. So let's see if it factors. The only difference between this and a regular quadratic is that instead of x here and here, I have x squared. So if I factor, I would put x squared and x squared. And let's see, 36 could break down into 6 and 6, but I don't know how that would add to 5. It also breaks down into 9 and 4, which could give us a negative 5. If we did minus 9 and plus 4, that would work. So then it's factored, it's set equal to 0, so we set each factor equal to 0 and solve. So over here we have two choices. We could either factor x squared minus 9 as the difference of two squares, or you could move the 9 over and take the square root of both sides, which is what I'm going to do. Don't forget that plus or minus when you take the square root of 9. Then over here we have x squared equals negative 4. Now you know right off the bat, no real number squared will ever equal a negative number, so this is going to give us two imaginary solutions. Taking the square root of both sides, we'd have x equals plus or minus the square root of negative 4. The square root of the negative turns into the I, and the square root of 4 becomes 2. Normally you would see that written 2i. So those are the two real solutions and two imaginary solutions to this equation. Now this next example is somewhat similar in that Actually, this one is a quadratic, but it's written in a way that can help us to solve it more quickly than doing this method and expanding, combining all the like terms, and solving for x. Because it's written where you have something squared minus that same something minus 6. So what you can do is substitute in a new variable. I'm going to call it y, but you can call it anything really. I'm going to let y equal x plus 4, and then I'm going to rewrite this equation in terms of y. If y is equal to x plus 4, then this is equivalent to y squared minus y minus 6 equals 0. So what I'm going to first do is solve this for y, and then I'll come back to this to solve for x, which is what we really want. So let's see, first off, does this factor? It looks like it may factor into y minus 3 and y plus 2. Yes, that will work. Setting each factor equal to 0 will give us y equals 3 and y equals negative 2. Now what we want is x though, so now we have to come back and solve for x. In fact, it might make more sense to solve this equation for x first. X is equal to y minus 4. So then for this first one we get y equals 3, but it's really x equals 3 minus 4. So x would be negative 1 in that case. Or if y was equal to negative 2, x would be equal to negative 2 minus 4, or negative 6. So that's one way to solve this. The other way would be to do, like I said, expand, combine like terms, and solve for x. So you could also FOIL this thing out, x plus 4 times x plus 4. And I'm going to distribute that negative x minus 4 minus 6 equals 0. FOILing gives me x squared plus 8x plus 16 plus x. These two terms combine to minus 10. Then we have x squared. 8x plus x is 9x. 16 minus 10 is positive 6. And let's see, this, it looks like I messed up here. This should be minus x. I changed that minus to a plus for some reason, so that should be 7x. Okay, now I can see that definitely does factor into x plus 6 and x plus 1. And so you can see how that's going to give us x equals negative 6 and x equals negative 1. Same answers. Okay, so this is a new option for you if you have something of this form. And it's a good one to practice because that technique will be useful in other situations as well. Here's another example. Now this is one that is unlike something that we've seen a lot of, but if you recognize that x to the 2/3 could be written as x to the 1/3 all squared, then this becomes a quadratic-like problem, right? Because to simplify this, you would multiply 1/3 times 2, which is 2/3. So I'm going to rewrite it like that. I'm going to write it as x to the 3rd all squared minus 7 times x to the 3rd, that's to the first power, plus 10 equals 0. So this is quadratic because it's a thing squared minus 7 times the thing plus 10 equals 0. It's quadratic-like in that the powers decrease from 2 to 1 to nothing. So if it factors, we would have x to the 3rd and x to the 3rd in place of the usual x. Let's see, they would need to add to negative 7 and multiply to positive 10, so how about negative 5 and negative 2 will work. Then we can set each factor equal to 0 and solve each of these equations to get x to the 3rd equals 5 and x to the 3rd equals 2. So to solve this equation, we would need to raise both sides to some power so that the 3rd goes away and we have simply x. So if we cube both sides, 3 times a 3rd is 1. So we'll just get x on the left and 5 cubed on the right, 125. Okay, now anytime you square or cube both sides, you do have to check your answer. So we will check that. We can check that by coming actually just right back up to here, because that's the point before we cube both sides. And if you check, 125 to the 1/3 power does in fact equal 5, so that works. And doing the same thing over here, cubing both sides. Oops, cube. We get x equals 2 cubed is 8, and in fact, yes, 8 to the 1/3 does equal 2, so that does work. So those would be the two solutions in this case. Now let's move on to a couple of applied problems. You do need to be able to do problems very, very similar to these two problems that we're doing, and similar to anything else that you encounter in your homework. Okay, when you're faced with an applied problem, read the problem over and over until you understand what the problem is saying and what the problem is asking for. Now the setup, I'm teaching you ways to set up these problems that you should be able to apply to all the other problems that you're doing. Okay, so in this example, we have Karen and Doug can clean a strip of beach in 5 hours. Alone, Karen can clean the strip of beach 1 hour faster than Doug. Find the time that each person can clean the strip of beach alone. Give an exact answer and a 1 decimal place approximation. Okay, now if you just read it, you might go, I don't know, that's too hard. Well, it's not too hard as long as you have a method for setting it up. Okay, so here's what we're going to do. We're going to look at it in two ways. We're going to look at the total time it takes each person to complete the job, and then the part of the job that they can complete in 1 hour. And that's how we're going to use that information to set up an equation that will then allow us to solve for the unknowns. Now before you can do anything, you have to define the unknowns. Notice there's no x's given. There's no variables in the problem. Oops. So if that's the case, we must define our variables. You can't just start throwing x's and y's and z's around without saying what they are. Okay, so a simple way to do it is to let x, let's see, now let's read it again. Together, Karen and Doug can clean a strip of beach in 5 hours. So together, it takes them 5 hours to clean a strip of beach. Alone, Karen can clean the strip of beach 1 hour faster than Doug. Okay, find the time that each person can clean the strip of beach alone. Now that's my key for where I'm going to get how to define x. Typically x is what you're looking for, right? Usually you solve for x. So it's easiest if you make x whatever it is that you're looking for. So this says find the time that each person can clean the strip of beach alone. So let's let x be the time it takes for one of them to clean the beach. And we'll have to define which person that refers to. So let's let x be the time it takes. How about Karen, since she's mentioned first? So the time it takes for Karen to clean the beach alone. If that's the case, then it says, then we need to define how long it takes for the other person, or Doug, to clean the beach. Okay, it says Karen can clean the strip of beach 1 hour faster than Doug. So if she can clean it 1 hour faster than Doug, then it takes Doug x plus 1 hours to clean the beach. Then x plus 1 is the time it takes for Doug to clean the beach. Now do not hesitate to write out words and sentences like this. This is really, really good method for helping you to understand what's going on. Okay, sometimes students think, oh, I can save time by not writing the sentence, but then they get confused and they spend 20 minutes trying to solve the problem. Whereas if they just explain to themselves what their variables meant, and which also explains it to me or grader, it would have been more clear and they would have been able to solve it actually faster. So don't assume that writing more takes more time. That's not true at all. Okay, so now that we have this information, we have our variables defined. Okay, and we're trying to find x. That'll allow us to solve the problem. That is the time it takes each person to clean the strip of beach alone. Let's set up a chart. a chart will help us out here. So there's three things on the horizontal that we should put, and that is their individual times. So we have Karen and Doug, and then the times that it takes for them to clean together, because that's also mentioned. It says together Karen and Doug can clean a strip of beach in that much time. So those are all important pieces of information. Now over here on this side we'll put the times it takes. So here let's put total time to complete job. Okay, so we know, let's see, Karen, the total time it takes Karen to complete the job alone is X hours. The total time it takes Doug to complete the job alone is X plus 1 hours. We already defined that. And together together they can clean a strip of beach in 5 hours. Okay, so that's important information. It's still not enough for us to set up an equation yet and solve, so instead of looking at total time it takes them to complete the job, let's look at what fraction of the job that they can complete in 1 hour. So over here I'm going to put part of the job completed in 1 hour. Now this is easiest to understand by looking at this last row down here. If they can complete the whole job in 5 hours, then what part of the job will they complete in 1 hour? Well, the answer would be 1/5 of the job, right? Because if it takes them 5 hours to do the whole job, then in 1 hour they can do 1/5 of the job. Okay, how did we get that? You just do 1 over the total time it takes for them to complete the job. So if it takes Karen X hours to complete the job by herself, then the part of the job that she'll complete in 1 hour is 1 over X. Okay, maybe it helps to think of it with numbers, right? Let's just imagine for a minute that X is 7, and I'm just making that up. I don't know what the answer is yet. But if it's 7, if it takes Karen 7 hours to complete the job, then in 1 hour she completes 1/7 of the job. So that makes sense. Okay, so you divide by total time to compute. So if it takes Doug X plus 1 hours to complete the total job, the part of the job that he'll complete in 1 hour is 1 over X plus 1. Now, why does that help us? Because this last column over here we can use to set up an equation that will then allow us to solve for X. Right? Because the part of the job, let's write it out in words. The part of the job completed by Karen in 1 hour plus the part of the job completed by Doug in 1 hour Now let's think about it. If you add together the part of the job completed by Karen in 1 hour plus the part of the job completed by Doug in 1 hour, then you'll have the part of the job completed by both of them working together in 1 hour. Now it might help to think of a more practical example. For example, if I clean half a kitchen in an hour and my husband can clean a quarter of the kitchen in an hour, then together we have cleaned 3/4 of the kitchen in 1 hour. So you add together the part of the job completed by one person with the part of the job completed by the other person in 1 hour to get the part of the job completed together in 1 hour. The nice thing is we have variable expressions for each of these three things. Okay, the part of the job completed by Karen in 1 hour we already figured out is 1 over X. The part of the job completed by Doug in 1 hour is 1 over X plus 1. And the part of the job they complete together in 1 hour is 1/5. And so now we have an equation in terms of X that we can solve. What type of equation is this? It's a rational equation, so we are going to have to multiply both sides of this equation by the lowest common denominator. Looks like the lowest common denominator in this case would be, let's see, we have a 5, we have an x, and we have an x plus 1. So we're just going to have to do the product of all three since they have no common factors. 5 times x plus 1 on the left, and 5 times x plus 1 on the right. Distributing that out, we get 5x times x plus 1 over x plus 5x times x plus 1 over x plus 1 equals, over here on the right we can cancel those 5's, so we just have x times x plus 1. Now that everything's factored, we have x over x plus 1 over x plus 1. So we end up with 5 times x plus 1 is plus 5x is equal to x times x plus 1. And maybe at this point you can or can't tell what kind of equation it is, so let's keep simplifying until we can tell. So let's distribute that 5 out to get 5x plus 5. Then we have this plus 5x is equal to x squared plus x. And yes, now we can see it is a quadratic. So let's get everything on one side. Let's see, and combine like terms. So I'm going to move all this stuff on the left over to the right. So we'll have 0 equals x squared. Now we have 5x plus 5x. That's 10x. So if I subtract 10x from both sides, I'll have x minus 10x, which is negative 9x. And if I subtract 5, we'll have minus 5. Okay, now I don't think that's going to factor because 5 would have to break down into 1 and 5, and there's no way to get a 9 out of that. So let's go straight to the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b. b is equal to negative 9, so negative b is positive 9. Plus or minus the square root of b, which is negative 9, squared, minus 4, times a is 1, times c is negative 5, all over 2 times 1 over 2a. And then from here we just simplify. So we have x equals 9 plus or minus, what's under this radical? Negative 9 squared is 81. Then we have minus a minus, so it's going to be plus. 4 times 5 is 20, all over 2. So we get 9 plus or minus the square root of 101 over 2. Now that's not going to simplify at all. So let's go back to the original equation problem. It says give an exact answer and a 1 decimal place approximation. Okay, so we're going to give both here. So the exact answer we would need to say is, it's not just x, remember, it asks for find the time that each person can clean the strip of beach alone. So Karen can clean the strip of beach in this many hours. So we'll say Karen takes, well actually we need to figure out which answer it is. There's two answers here. So let's figure out, if we do the one with 9 plus radical 101 divided by 2. This is the one with the plus. I get about 9.5249. If we do the one with the minus, 9 minus radical 101 all over 2, I get negative 0.5249. That one's not going to be the answer because it's negative and she can't clean it in a negative amount of time. So it must be the positive one. So Karen takes 9 plus the square root of 101 over 2, which is approximately 9 point, let's see how many decimals are we rounding to. This is a 1 decimal place approximation. So 9.5 hours. And then Doug takes an hour longer. So Doug would take, his exact time would be 9 plus radical 101 over 2 plus 1, which would be about 10.5 hours. So there is our solution to this problem. So if you have a problem similar to this is how you would set it up to solve it. Write out the total time for each person to complete and the time for them to complete the job together. Then the part of the job they complete in 1 hour. And you make a chart and then you set up equation using this fact. Okay, you'll need to memorize that setup there. Let's do another applied problem. This one is a little bit different, but not too different. Okay, a family drives 500 miles to the beach for a vacation. The return trip was made at a speed that was 10 miles per hour faster. Total traveling time was 18 1/3 hours. So find the speed to the beach and the return speed. Okay, again, we're given no variables. There's no x's, no anything here. Now there is the one equation that you need to know, and that is that distance is equal to rate times time. Distance equals the distance you travel equals the rate at which you travel times the amount of time that you travel for. It's often just written D equals RT. So if a family drives 500 miles to the beach for a vacation, that means their total distance they're driving is 500, at least from point A to point B. Now the return trip was made at a speed that was 10 miles an hour faster, so that's referring to the rate. Okay, the total traveling time was 18 1/3 hours. That's total time. Find the speed to the beach and the return speed. That's our key for what our variables should be here. Find the speed to the beach and the return speed. Now you could do this two ways. One is you could introduce x's, or two, you can just stick with these variables over here, D equals RT. And that's what I'm going to do, is just stick with D equals RT. So there's two different rates though. So let's split the board into two parts. We have going to the beach and then there's returning. So when they go to the beach, the distance is equal to rate times time. That's true. The rate at which they go, I'm going to call that rate go, R subscript go, to indicate that's the speed at which they go to the beach, and the time it takes them to go to the beach. So I'm going to call that T sub go, for time it takes them to go to the beach. Now the distance at which they go to the beach is the same when they're going to the beach and when they're returning to the beach. They travel the same distance each way, right? 500 miles. So there's no need to have two separate D variables. Now when they return, this equation is also true. Distance equals rate times time. But when they return, their rate is different than the rate over here. So these are two different R's. So let's call this one rate going back, and the time it takes them to go back. That's supposed to say back. Okay. So like I said, we already know that the distance that they travel each way is the same. That's 500. So let's go ahead and plug that in. So that'll get rid of the D's. So we know that 500 is equal to the rate at which they travel on the way there times the time it takes them to travel. And 500 equals the rate at which they go back times the time it takes them to go back. Now let's see, what else do we know? We know that the return trip was made at a speed that was 10 miles per hour faster. That's key, okay? That means the rate at which they traveled back is equal to the rate at which they went plus 10, because it's 10 miles an hour faster than the rate at which they traveled there. So I can then replace that by the rate at which they go plus 10. Okay? And let's see, what else do we know? There's one more thing we know here, and that is that total traveling time was 18 1/3 hours. That's total traveling time. So down here kind of in the middle, that means the time it took them to go to the beach plus the time that it took them to come back from the beach. We know that that total time equals 18 1/3. So what I could do is I could solve each of these two equations for time and then add them together down here. So to solve this equation for time, we would need to divide by the rate. So we'd have 500 over the rate at which they go to the beach equals the time at which they go to the beach. And over here to solve for t, we divide both sides by r go plus 10. So we'd have 500 over r go plus 10 is equal to the time it takes them to come back. So the time it takes them to go is that, and this is the time it takes them to come back. So plugging each of those in, we have 500 over the rate at which they go to the beach plus 500 over the rate at which they go to the beach plus 10 is equal to 18 1/3. Now this is an equation that we can solve for r sub go. And if you, at this point, if you just want to drop the go's and call it r, that's fine because these are the same r. Up here, it was necessary to differentiate between this r and that r because they were different. That's why I used subscripts. Okay, so we'll just drop the go's for now, call it r. 18 1/3, that's a mixed number, which is not real fun to work with when solving equations. So let's write that as an inappropriate fraction, or an improper fraction. 18 times 3 is 54, so 54 plus 1, that's equal to 55/3. I prefer that over this mixed number. Okay, so to solve this equation, it's a rational equation. We're going to need to multiply both sides by the lowest common denominator. Looks like it'll be 3 for that fraction right there, times r for that, times r plus 10 for that. So 3r times r plus 10 on each side. And we distribute on the left to get, let's see, we have, when we distribute this, let's just go ahead and skip this baby step I've been doing. When we distribute 3r times r plus 10 times this fraction, the r's are going to cancel. This r will cancel with this r. So we're going to have 3 times r plus 10 times 500 plus, now when we distribute it over the second term, this r plus 10 will cancel with that r plus 10. So we're just going to be left with 3r times 500. And on the right, those 3's cancel, so we get 55r times r plus 10. And we need to keep going to see what kind of equation this is. 3 times 500 will be 1500 times r plus 10. 3 plus 1500r is equal to 55r times r plus 10. Need to keep going, keep distributing and simplifying, so this would be 1500r. And actually, no, before I simplify, let's look for something that we can divide all three of these numbers by, because 55 and 1500 are huge numbers. So let's see, I know that they're all divisible by 5. I think that's all we can do. So if we divide both sides by 5, this on the left will become 1500 times r plus 10 over 5 plus 1500r over 5 equals, let's see on the right, 55 over 5 simplifies to 11 and 1, so we just have 11r times r plus 10. And let's see, 1500 divided by 5 is 300, so we have 300 times r plus 10 plus 300r equals this. Now let's go ahead and distribute this out on the right to give us 11r squared plus, let's see, 11 times 10 is 110r. Distributing out on the left, we get 300r plus 3000 plus 300r. So it is a quadratic. We do need to combine like terms and get everything equal to 0 on one side. So I'm going to subtract everything over to the right side to get me 0 equals 11r squared. Then we have 110r minus 300r minus another 300r. So 110 minus 600r will give us negative 490r. Then moving that over gives us a minus 3000. Now I'm definitely not even going to attempt to factor that. Even if it does, it's not worth my time to try. Better to just go straight to the quadratic. to give us r equals, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get, let's see, negative b would be positive 490 plus or minus the square root of b squared is 490, negative 490 all squared. Let's just go ahead and square it. Negative 490 all squared is 240 100 minus 4 times a, that's 11, times c is negative 3000. All over 2 times a, which would be 22. So let's see what that comes to under the radical. This would be 4 times 11 times 3000. So I get the square root of 24,100 plus 132,000. Hopefully this will simplify a little bit. Adding those two numbers together, I get 490 plus or minus the square root of 260, oops, let's write that again, plus or minus the square root of 264,000. Now let's see if that has an exact square root. And it does not. Now you could simplify this, but it would take you a long time. So, and ultimately I think we just want an applied answer anyways. And by that I mean a rounded answer anyways. Actually, I just realized that I made a mistake not too far back. It was in just adding under these radicals right here. 4 times 11 times 3,000 is 132,000, but when you add that to 240 100, you should get 372 100. $37,200, 100. If you take the square root of that, it actually is an exact square root. Yeah, it shouldn't have been that messy. So we get 490 plus or minus 610 all over 22. Much better. Then from here, we need to see what each of those is. Probably one will make sense and one won't. So if we do the 490 plus 610 over 22, let's see what that comes to. 490 plus 610 divided by 22 comes exactly to 50. Or if we do 490 minus 610 over 22, you can tell right there it's negative because 490 minus 610 is a negative number, so that can't possibly be the solution. So the rate, remember this was r, we had dropped the subscript way back here, but this was the rate at which they went to the beach. That was the rate at which they would go. So the rate at which they would go to the beach is 50 miles per hour. And that works. We had a rational equation, but 50 won't give us a 0 in either of these denominators, so that's fine. The question, let's go back and answer the question. It says find the speed to the beach and the return speed. So the speed to the beach was 50 miles an hour. Now the speed going back was 10 more than that. So the speed, or the return speed, call it r back, was 60 miles per hour, 10 more. Okay, so make sure that you can set up and solve distance equals rate times time type problems. There is a slightly different method of setting it up in a chart in your book. So if you're more interested in doing it the chart way and using x's instead of r's and t's and d's, you could do that by following the method in your book. That's it for this section. Tune in next time for 11.4.